Problems based on trigonometric ratios and identities. So today we are dealing with problems in addition. Let me take chapter 5, trigonometric ratios. This is 5.1 question number 1. So let me write the question. Cos A equals to 4 by 5. Find other ratios. So first I am going to find the sine. If you get the sine value, already cos is existed, then we can find remaining 4 based on these two. So I am taking sine square A plus cos square A equals to, which is well known identity from this. Sine square A equals to 1 minus cos square A. That means sine A equals to under root of 1 minus cos square A. I am bringing square to this side, it becomes root. Now sin A equals to under root of 1 minus, substitute the value of cos A, 4 by 5 here, and you will get 4 by 5 whole square. Then sin A equals to under root of 1 minus 16 by 25. Then sin A equals to under root of, take 25 as the LCM, then here will be 1, so 1 into 25, 25, so 25 minus 16 as it is here. From this, sin A equals to under root of 9 by 25, square root of 9 is 3, square root of 25 is 5, therefore sin A is equals to 3 by 5. So let me go with the tan now. Tan A equals to sin A divided by cos A. Okay, let me get the ratios here. 3 by 5 whole divided by 4 by 5. So 5 it get cancelled. 3 in the numerator, 4 in the denominator, which is 3 by 4. Therefore tan A equals to 3 by 4. Now we can go with the cosecant A, which is the reciprocal of sine. Cosecant A equals to 1 by sine A, that means 1 divided by 3 by 5, which gives rise to 5 by 3. Therefore cosecant A equals to 5 by 3. Then the reciprocal of cos, which is secant, secant A equals to 1 by cos A, that means 1 divided by 4 divided by 5, which gives 5 by 4. Therefore secant A equals to 5 by 4. Last one, which is cot A equals to 1 by tan A, that means 1 divided by 3 by 4, which gives here 4 by 3. Therefore cot A equals to 4 by 3. So here are the 5 ratios we need to find. Next problem, same exercise, question 2. So let me write the question 2. In a triangle ABC, right angle at B, means given that in triangle ABC, B is the right angle, and also given the sides AB equals to 24 centimeters and BC equals to 7 centimeters. So we need to find here sine C, cos. So let me get the figure. Now triangle A B C. he given AB is equal to 24 centimeters, BC equals to 7 centimeters. We need to find sin C and cos C. So angle here. No. Take sin C. What is the ratio of sin C? Opposite side by hypotenuse. So see, now we have the opposite side of C, but we are missing with hypotenuse. So we have to find the hypotenuse first. That means AC square equals to AB square plus BC square. Then AC square equals to 24 square plus 7 square, which gives here 576 plus 49. That means AC square equals to 625. Then AC equals to under root of 625, which gives you 25. That means the length of the hypotenuse is nothing but 25 centimeters. Now substitute the values here. Sin C equals to opposite side of angle C is 24. Then hypotenuse is 25. So sin C is 24, 25. Next, cos C equals to adjacent side by hypotenuse. So the adjacent to angle C is 7. The hypotenuse is 25. Therefore, cos C equals to 7 by 25. Okay, can go with the next problem. Same chapter 5.1. Taking now 10th problem. Let me write the question. If 3 tan theta equals to 4, then find the value of cos theta plus sin theta Let me write the question. If 3 tan theta equals to 4, find the value of 4 cos theta divided by 4 cos theta minus sin theta whole divided by 2 cos theta plus sin theta. So before going to the solution, so what he given? He given 3 tan theta equal to 4. He didn't given the tan theta directly. So make the standard form tan theta, then you get the ratio of tan theta and convert here in the ratios of tan, then you can be very easy to solve the problem. Take the given 3 tan theta equals to 4. From this, tan theta equals to, bring 3 to right side, will become by 3. So this is the standard ratio. Keep it as it is. Now consider what we have to find. 4 cos theta minus sin theta whole divided by 2 cos theta plus sin theta. If you observe, we have the value of tan theta. If you convert any one of this into tan theta, you can solve this easily. So divide numerator and denominator with cos theta. See what will happen. 4 cos theta minus sin theta divided by cos theta whole divided by 2 cos theta plus sin theta divided by cos theta. So split them. Four cos theta divided by cos theta minus sin theta divided by cos theta whole divided by 2 cos theta divided by cos theta minus sin theta divided by cos theta. Now here cos and cos get cancelled. The numerator also same thing. Cos and cos get cancels. This gives 4 minus, if you observe sin by cos, it is nothing but tan. 4 minus tan theta whole divided by 2 minus tan theta. Substitute the value of tan theta. 4 minus 4 by 3 whole divided by 2 minus 4 divided by 3. So you can take the LCM in numerator 3 as well as in the denominator. Okay, here 1 into 3 3 times, so 4 3s 12 minus 3 here and LCM also 3, obviously it will be the same number 4, then whole divided by again LCM here you get 6 minus 4, so 3 will get cancelled, so 12 minus 4 is nothing but 8, 6 minus 4 is nothing but 2, so 2 ones 4, that equals to 4, so that's what we have to find. Okay, problems based on trigonometric identities. R.D. Sharma chapter 6 trigonometric identities, exercise 6.1, question number 1. Here the question: 1 minus cos square a into cosecant square a equals to 1. So we have to prove that 1 minus cos square a into cosecant square a minus 1. If you observe here, 1 minus cos square a, it can be written as sin square a using the identity, then sin square a and cosecant square a, which are reciprocals, will become 1. Now see, take LHS. 1 minus cos square a into cosecant square a. Right, let's write the identity. Sin square a plus cos square a equals to 1. So transpose cos square a to right side, then you will get sin square a equals to 1 minus cos square a. That means we can replace 1 minus cos square a as sin square a. So replace it into cosecant square a. Again I can write the sin square a as 1 minus 1 by cosecant square a, which is reciprocal, into cosecant square a. Both will give cancels and you will get 1. So which is RHS. We shall move for next problem. Same chapter, same exercise, question number 20. Let me get the question once. 20. Tan square theta minus sin square theta is equals to tan square theta into sin square theta. So we have to prove that tan square theta minus sin square theta equals to tan square theta into sin square theta. If you observe that, if you convert this, because here we have only single term, in order to convert this single term we have to take anything common from these two. In sin square leave like this, but in tan square we have hidden sin. So if you convert this into sin and cos, then you can take sin as common. Let me try. LHS tan square theta minus sin square theta. All of you know that tan theta equals to sin theta by cos theta. So replace this here, we'll get sin square theta by cos square theta minus sin square theta. Here in these two terms sin square theta is common. Let me take it out, sin square theta, then here you're left with 1 by cos square theta minus 1 here. So sin square theta into, all of you know that 1 by cos reciprocal of cos is nothing but secant theta. So I can replace here and write as secant square theta minus 1. All of you know that 1 plus tan square theta equal to secant square theta. From this, tan square theta equals to secant square theta minus 1. I am transposing 1 to right side. That means I can replace secant square theta minus 1 as tan square theta. Replace that. Sin square theta into tan square theta. That's what I asked. Tan square theta into sin square theta. That is RHS. So we shall move for next problem. Same chapter, same exercise, question number 37. Let me get the question once. Under root 1 plus sin A divided by 1 minus sin A. So prove that should be equals to secant A plus tan A. So let me take LHS first. Under root 1 plus sin A whole divided by 1 minus sin A. So let me rationalize the denominator here. So the denominator 1 plus sin theta, sin A. So multiply 1 plus sin A with numerator and as well as denominator. So 1 plus sin A by 1 minus sin A into 1 plus sin A divided by 1 minus sin A. If you observe carefully, here 1 plus sin A, 1 plus sin A, same term, I can write it as square 1 plus sin A whole square whole divided by 1 minus sin A, 1 plus sin A. So A square minus B square formula, see, A minus B into A plus B. So A square minus B square, that means 1 square minus sin square A. Let's split numerator and denominator. So 1 plus sin A whole square divided by under root cos square A. Let me know, identity, sin square A plus cos square A equals to 1. From this, cos square A equals to 1 minus sin square A. I am transposing sin to, let me get the identity, sin square A plus cos square A equals to 1. Transpose sin square A to right side, then you'll get cos square A equals to 1 minus sin square A. That means in the place of 1 minus sin square A, we are replacing cos square A. That's what I had done here. Now see now. Here we can cancel square and root. Similarly here square and root. Then you will get So I'm splitting numerator and denominator separately. So under root 1 plus sin a whole square whole divided by under root 1 minus sin square a. Write the identity. Sin square a plus cos square a equals to 1. From this, cos square a equals to transpose sin square a to right side, then you'll get 1 minus sin square a. So here in the place of 1 minus sin square, I can replace cos square a. Let me do it. Square root of 1 plus sin a whole square whole divided by square root of cos square a. I am replacing here 1 minus sin square as cos square a. Square root will cancel, square root will cancel, and you will left with 1 plus sin a whole divided by cos a. That means split this 1 by cos a plus sin a by cos a. 1 by cos is nothing but secant a, sin by cos nothing but tan a. So which is RHS, secant a plus tan a. Let me move to next problem. Same exercise, question number 43. Let me get the question once. Cosecant a whole divided by cosecant a minus 1 plus cosecant a whole divided by cosecant a plus 1. So we need to prove this equals to 2 secant square a. As usual, let me consider LHS. Cosecant a by cosecant a minus 1 plus cosecant a by cosecant a plus 1. I'm writing the LCM. Cosecant a minus 1 whole into cosecant I'm taking the LCM here. Cosecant a minus 1 into cosecant a plus 1. So this is the LCM. So cosecant a into cosecant a plus 1. That equals to, take LCM here, cosecant a minus 1 into cosecant a plus 1. So here numerator is cosecant a into, it will goes cosecant A plus 1 times, so into cosecant A plus 1 plus cosecant A into cosecant A minus 1. Okay, so multiply cosecant A and cosecant A, you'll get cosecant square A plus cosecant A into 1 cosecant A plus cosecant A into cosecant A cosecant square A minus cosecant A whole divided by A minus B into A plus B, A square minus B square, that means 1 square, nothing but 1. Now this will be cancelled, then you left with cosecant square A plus cosecant square A, that means 2 cosecant square A whole divided by cosecant square A minus 1. Again from here 2 into cosecant square A by cot square A, because 1 plus, we know that 1 plus cot square A equals to cosecant square A. So transpose 1 to right side, then you'll get cot square A equals to cosecant square A minus 1. So that's what I replaced, cosecant square A minus 1 is replaced with cot square A. Now again cosecant square A means 1 by sin square A whole divided by cot square A means cos square A whole divided by sin square A. Now sin square A, sin square will cancel, we'll left with 2 into 1 by cos square A. Well, if you know that reciprocal of cos is secant, so 2 into secant square A, which is RHS. Let me end of the session.